year 2024, the realm of aviation will undergo a profound transformation. The imminent decision by the US Air Force to crown the victor of the sixth-generation NGAD fighter competition marks a pivotal moment. As the curtains rise on this epochal event, the next-generation air dominance fighter emerges as the designated successor to the illustrious F-22 Raptor, with ambitious plans to manufacture approximately 200 units. Prepare yourselves, for the horizon heralds the advent of a novel epoch in air supremacy. Remember to like and subscribe for more updates on aviation advancements. Behold the NGAD fighter, not merely a solitary aircraft, but an extensive array of interconnected systems poised to supplant the F-22 Raptor as its generation's foremost air superiority platform. At its core lies a piloted fighter craft, boasting technological advancements characterized by its sophistication, hyper-stealth capabilities, and the moniker PCA, denoting its role in penetrating counter-air operations. What sets the NGAD fighter apart from its predecessors? A fundamental departure lies in its tailless configuration, eschewing traditional vertical tails. This design choice stems from a strategic imperative to mitigate the aircraft's radar cross-section, enhancing its stealth characteristics and minimizing the risk of detection. Furthermore, the absence of vertical tails curtails aerodynamic drag, fostering heightened speed and efficiency in flight. Although this departure may sacrifice maneuverability, innovative solutions such as thrust, vectoring engines, and adaptive control surfaces managed by onboard flight computers offer a compensatory measure. Superior maneuverability takes a back seat to other paramount considerations for the NGAD fighter, namely stealth, extended range, and the integration of unmanned aerial vehicles to augment its operational capabilities clandestinely. The NGAD's exhaust outlets are meticulously concealed to attenuate its infrared signature. This is vital in an era where adversaries increasingly rely on infrared search and tracking systems to detect stealth aircraft. Thermal management is critical as the NGAD traverses the skies, generating discernible heat signatures along its forward edges. To combat this, cutting-edge radar-absorbing materials and RAM coatings are employed to not only scatter radar waves, but also diminish the aircraft's thermal footprint. This transformation in aviation heralds an era of unparalleled capabilities and strategic prowess, epitomized by the NGAD fighter's design philosophy. Yet beneath the veneer of technological innovation lies a sobering truth: the fearsome price of omission. As the world beholds the NGAD fighter's ascent, a shadow looms over those who fail to grasp its significance. Remember to like and subscribe for more updates on the future of aviation. In recent sightings, aircraft enthusiasts and military observers alike have been captivated by the sight of F-22s and F-35s adorned in striking chrome or mirror-like finishes during test flights. These unique appearances are not merely cosmetic enhancements, but indicative of a deeper purpose, serving as test beds for the latest advancements in radar-absorbent material, RAM coatings. Within the secretive realm of the NGAD program, every flight is a meticulously orchestrated endeavor to perfect the art of aerial invisibility, thus solidifying its status as the ultimate embodiment of air superiority. Its cockpit is central to the NGAD fighter's arsenal of stealth technologies, meticulously engineered to minimize its radar cross-section. Unlike conventional cockpit designs, which often serve as vulnerable detection points, the NGAD fighter's cockpit seamlessly integrates into the fuselage, featuring a minimalist configuration with only two discrete side windows. Rather than compromising stealth, these windows serve solely as visual reference points for the pilot. Operating within this sleek cockpit environment, aviators are poised to leverage the full potential of cutting-edge technologies, such as the Distributed Aperture System (DAS). This advanced system, already employed with great success on the F-35 platform, revolutionizes situational awareness by providing pilots with a comprehensive panoramic view of their surroundings. Through a network of strategically positioned cameras dispersed throughout the aircraft, the DAS enables pilots not only to peer behind them, but also to see through the very structure of their plane, transcending conventional limitations of visibility in combat scenarios. Thus, as we delve deeper into the intricacies of the NGAD program, it becomes evident that every facet of its design and operation is meticulously crafted to uphold its unparalleled standard of stealth and superiority in the ever-evolving theater of aerial warfare. What defines a fighter, if not its armaments? Within the NGAD program's realm, weaponry development is as integral as its stealth capabilities. Crafted to maintain a formidable offensive edge without compromising its stealth profile, the NGAD fighter ingeniously conceals its arsenal within internal bays strategically positioned toward the aircraft's rear. This tactical design ensures the aircraft remains sleek and undetectable while poised to unleash devastation upon adversaries foolish enough to challenge its aerial dominance. Envisioning the notional concept of the NGAD fighter, we find a sophisticated arrangement within its internal base. The outer compartments stand ready to house lighter munitions, such as air-to-air missiles, which are ideal for defensive maneuvers during strike missions or asserting air superiority in combat engagements. Meanwhile, the inner bays boast enhanced carrying capacities, earmarked for heavier ordnance including laser-guided bombs, cruise missiles, and potentially even nuclear weapons. With this diverse payload, the NGAD fighter emerges as a formidable force prepared to confront any threat to its airspace supremacy. The NGAD fighter signifies more than a mere replacement for its predecessor, the F-22 Raptor. It heralds a new era in aerial warfare dominance. While the Raptor showcased exceptional capabilities, its limited operational range posed challenges in the dynamic theaters of conflict, particularly in the vast expanses of the Pacific. Recognizing this strategic imperative, the NGAD fighter prioritizes extended range capabilities, relying solely on internal fuel reservoirs to traverse vast distances without compromising its stealth profile. In a departure from conventional design paradigms, the NGAD fighter forego vertical tail structures, prioritizing fuel efficiency and range optimization. This deliberate choice underscores the imperative of maximizing endurance while maintaining a blistering top speed. By embracing the ability to supercruise to sustain supersonic flight without the need for afterburners, the NGAD fighter achieves unprecedented fuel efficiency, mitigating the risk of detection posed by conspicuous afterburner plumes. The significance of high top speeds in sixth-generation fighters cannot be overstated, as it directly influences the efficacy of missile launches and extends the operational range of weaponry. This becomes especially pertinent in hypersonic weapons, where speed is paramount to weapon effectiveness. In pursuit of these objectives, the NGAD fighter's innovative design incorporates a double delta wing configuration, drawing inspiration from predecessors like the F-16XL and SOB Draken. This aerodynamic marvel balances high-speed performance with exceptional handling qualities across diverse flight regimes, featuring a hybrid wing design optimized for supersonic efficiency and subsonic maneuverability. Pushing the boundaries of aviation engineering, the NGAD fighter introduces a revolutionary modification to the traditional delta wing, incorporating a chopped outer panel for enhanced performance. Although this design alteration necessitates a more sophisticated flight control system, the technological advancements since the era of the F-16XL render this evolution not only feasible but essential to achieving quantum leaps in aviation design. The imperative for the next-generation air dominance NGAD fighter is unmistakable in light of the complex geopolitical landscape, yet the looming question extends beyond necessity to the considerable financial investment it demands. The projected price tag per unit of the NGAD fighter is nothing short of staggering, reaching several $100 million per aircraft, thus positioning it as the most expensive weapon system in history. Should the objective entail a one-to-one replacement of the F-22 fleet, approximately 180 NGAD fighters would be requisite. However, recent proposals from the Air Force advocate for a bolder procurement strategy, envisioning the acquisition of 1,000 collaborative combat aircraft, CCAs. What sets this plan apart is its innovative approach, which advocates for a ratio of 2 unmanned aircraft for every NGAD fighter or F-35. This blueprint entails a fleet composition comprising roughly 200 NGAD fighters alongside 300 F-35s, with the remaining 500 jets consisting of drones of diverse sizes and capabilities. Contrary to prevailing perceptions, these drones are not merely disposable assets. Instead, they represent a paradigm shift towards a concept of affordable mass warfare. Intended for reuse after each mission, these drones are designed to undertake risks that may prove impractical for manned aircraft. Initially deployed in air-to-air engagements, these drones are expected to evolve their capabilities as artificial intelligence and tactical methodologies advance, expanding their role to encompass air-to-ground operations. Moreover, the versatile pool of 500 drones can be flexibly deployed to complement either NGAD fighters or F-35s, ensuring a consistent 2-to-1 ratio of unmanned to manned aircraft. While the NGAD fighter stands as a revolutionary marvel, its acquisition is accompanied by daunting financial implications commensurate with its unparalleled capabilities. To realize its potential to dominate the skies, the NGAD must be engineered efficiently, facilitating streamlined production, upgrades, and maintenance from its inception. Embracing modular design and standardized interfaces emerges as the most promising approach, enabling systems to be dissected into interchangeable components akin to USB ports or Lego bricks. As USB ports foster seamless connectivity between devices, standard interfaces enhance compatibility and interoperability while minimizing the need for disparate cables or connectors. The NGAD program stands to reap substantial benefits from adopting these methodologies, a direction already embraced by the 6th-generation B-21 Raider. Alternatively, fostering a collaborative design ethos involving multiple contractors and stakeholders in the developmental process presents another viable avenue. While this approach may entail marginal compromises in security, it promises to distribute costs equitably and facilitate the production of larger aircraft quantities, thereby serving as a mitigating factor. Ultimately, the most formidable challenge confronting the NGAD may not emanate from its adversaries, but rather from the prospect of insufficient production rates and numerical adequacy, akin to the hindrances faced by its predecessor, the F-22. While the NGAD fighter is not impervious, a substantial inventory could enable it to assert aerial dominance like never before. Indeed, its capacity for extended range, supercruise capabilities, and minimal radar cross-section epitomize the ambitious design objectives driving its development. Integrating stealth drones into multifarious roles, ranging from reconnaissance and air-to-air interceptions to sensor augmentation and defensive perimeters, signifies a transformative leap forward in aerial combat. Consequently, the NGAD fighter and its associated platform emerge as the next evolutionary milestone in aerial warfare. Speculations abound regarding the potential obsolescence of traditional frontline fighters, with discussions revolving around the emergence of unmanned iterations of both the NGAD and the B-21 Raider. This juncture in aviation history mirrors the transition witnessed from propeller-driven fighters of World War II to the advent of the jet age. Anticipation mounts as the announcement of the NGAD fighter competition winner looms on the horizon in 2024. Meanwhile, continuous updates and insights will be shared through ongoing video presentations and enhancements to the 3D model, offering enthusiasts an immersive experience of the evolving landscape of aerial warfare. A comprehensive video exploration awaits those seeking further elucidation on the design principles guiding the NGAD, akin to those of the B-21 Raider. Thus, armed with this knowledge, the truth behind the NGAD's transformative potential becomes abundantly clear.